Welcome to the Sonokit instruction video. This video shows you how to install a complete Sonoflow ultrasonic flow meter onto an existing empty pipeline without dismantling any part of the pipe. This is the Sonokit. Here's all you need to build your ultrasonic flow meter. On the lid of the box there's a table of contents which shows what's contained in the kit. This is the Sonokit manual, which describes the process from start to end. Follow the manual step by step and you'll find it easy to make the installation. These are the components which a Sonokit can contain. To be able to determine the construction of the flow meter, we have to get some data on the pipeline. The data we need is the circumference and the pipe wall thickness. The pipe diameter can be calculated by means of the formula circumference divided by pi equals diameter. We'll now start constructing a meter on the supplied roll of paper. Draw a line through the center of the paper. We call this line XX. Approximately 10 centimeters from the edge of the paper, we draw a point which we call X1. From the point X1, we draw a line at right angles to the line XX. On the new line, we draw the point A. The distance from X1 to A, which we call little a, is the quarter circumference of the pipe. If we want to construct a two-track meter, we must draw a point on each side of A. These points are called P1 and P2. The distance between A and P is called little d. Little d is calculated as at d multiplied by the pipe circumference. At d is taken from the table in the manual. Now a point called X2 must be drawn on the line XX. The distance between X1 and X2 is called little b. If we want to construct a two-track meter, little b is calculated as at b multiplied by the pipe circumference. At b is taken from the table in the manual. When constructing one-track meters, little b is calculated as 0.5774 multiplied by the pipe diameter. P3 and P4 are calculated using the same method as P1 and P2. We go through the different steps again. Little a is the distance from x1 to A and from x2 to A. Little d is the distance from A to P2, from A to P1, from A to P3, and from A to P4. If we want to construct a one-track meter, the sound track goes from A to A. If it's a two-track meter, the sound track goes from P1 to P3 and from P2 to P4. We've now finished the drawing and can proceed to the next step. To place the drawing correctly on the pipe, we must find the top line of the pipe. This is done as shown here with a level instrument. Draw 4 to 5 marks on the top of the pipe. Then draw a line through the marks you've drawn. The top line has now been found. The drawing can now be placed on the pipe. Note that the line XX on the drawing must coincide with the top line of the pipe. We're now at a real two-track Sonokit installation at a wastewater treatment plant in the Netherlands. Having measured the circumference and having made the drawing, we can place the drawing as we saw earlier in the film. Here we see how the points P1 and P2 are marked with a centre punch. Make sure that the lines are marked outside the circle so the cross lines can be recreated after the holes have been made. The holes can be made with a fire torch. Or with a special hole saw as shown here. Which method you use depends on the pipe material you work with. The next step is mounting the parts to hold the ultrasonic transducers. To ensure that the ultrasonic transducers will be aiming at each other, alignment rods are used during installation. The pipe wall thickness is measured to be able to calculate the actual internal diameter. The mounting plates are fastened to the pipe with a pair of tack welds. Before welding the plates all the way around, you must check that the marks on the pipe and the lines on the mounting plates coincide. When the mounting plates have been tack welded on each side of the pipe, check that the transducer holders slide into place easily. When the alignment rods and the transducer holders are in the right position, you can weld the mounting plates all the way round. Make sure that only the mounting plates are welded. When the mounting plates have been welded on, it must be checked that everything's in the right position. The transducer holders must be led into the mounting plates and pipe until aligned with the internal pipe wall. To ensure this, a mark's drawn on the transducer holders. The diagonal line on the mounting plate must be aligned with the line on the transducer holders. Then the transducer holders tack welded in 3 or 4 places. Don't forget to remove the alignment rod before you finish welding, otherwise it'll jam because of the heat from the welding. When it's been mounted, the next step's to measure the new sensor. The angle of the soundtrack in relation to the pipe is measured with an angle meter as shown here. A small level meter can be applied to get the angle meter in the same plane as the pipe. It's important that the angle reading's accurate, as the track angle has a great influence on the measuring accuracy. The measurements read must be entered in a measurement report, which can be found in the manual. The length of the soundtrack's measured by inserting the alignment rods in the transducer holders. Then are marks placed on the alignment rods. Having removed the alignment rods, the distance can be measured with a steel measuring tape. The The track displacement of the sound tracks is also measured with a measuring tape. The measure for 1 track meters is 0. The length of the cable between sensor and signal converter must also be registered in the measurement report. The internal diameter is calculated from the circumference and the measured pipe wall thickness. If there's an internal layer in the pipe, this must also be included. Signal cables and power supply are connected to the signal converter. Finally, data must be entered into the signal converter. These data are, among others, the sensor geometry data, which can be read in the measurement report and the flow rate. The measuring system is now ready for operation.